I love these. I do. It's a factor fest and a cancel fest. However, we got to just keep track of the fact if there is a divided by, we need to change it to a times. But before we forget, we got to make a note that we have to turn those things over. Okay? This right here, this doesn't change. We're not dividing this. It's this divided by this existing fraction, which is why we can turn it around and say we're multiplying by the reciprocal. The only thing that we can really factor is this thing here. And those are going to be conjugates because those are the difference of two perfect squares. X plus 5, x minus 5. I'm going to go ahead and manually put this up here, x plus 5, so I've moved that. X squared down on the bottom, I've moved it. So, cancel the x minus 5s, cancel the x plus 5s. It looks like there's nothing left on top, and I get this an awful lot. Shame on you, shame on all of us for me letting you do that. If we know this is on the bottom, and it is, there's no way, the assumption here is that it's over 1, not that it's under 1. So if it is in fact have a 1 on top, show it. You have to show it, otherwise you've done something wrong. I'm doing it. Let's go. There's not much to say, so let's just get to factoring. Two numbers that multiply together to get 6, add together to get negative 5. X minus 2 and x minus 3. They'll multiply to get the positive and add together to get the negative. This one factors x plus 3 and x plus 1. Plus 1s are gone, the minus 2s are gone. These cannot reduce. X plus 3 and x minus 3 is the final answer. Some folks will try and cancel that and call it a negative 1, but just picture a 10 in here. If it's a 10 plus 3, that's 13. A 10 minus 3 is 7. 13 over 7 has nothing to do with the number negative 1. So if you're teetering, you can always plug something in and see if you're saying this is negative 1, it should work as negative 1 with any x value, and that's a counterexample right there.